Alright, at last we have made it to a Functional-1. So, before we can get into this, I kinda have to talk about a lot of things. So, the first chunk of this video is going to be me going over some other things. I'm going to introduce you to some of the broader scoped things of Java. Because right now, all the things we've been doing have just had to deal with one method. And occasionally we've written helper methods to assist with those, but really our entire life has been just in one method for these CodingBat problems. So I'm going to introduce you to some of the broader things in Java. So I've alluded to the fact that classes are a thing in Java, and that a class holds a bunch of methods. Now a class actually has several roles. So I'm going to make a new class here, and I'm going to call it person. And And so classes, basically they have several roles. They can, I'll put this in a comment here, they can, and let me just hide this here so we can focus on what we need to focus on. So basically, classes have a few roles. They store methods, they can store variables like in the class, and so they can store methods, they can store variables, and they define types and the behavior of those types. So types and their behavior. Okay, so it does all of these things. So basically, let's talk about this class real quick. So basically, we have a person, and just by writing this class, just by writing the way you make a class, you just type the word class, and then you do the name of the class. Classes usually start with a capital letter. Then you put these two curly braces to denote the body of that class. So just by declaring that class, you have created a new type called person. This is a new type in the language like string or list or map. It's a new type that we just created. So I can create variables of this type, right? And so this type is going to be a reference type. You can only create reference types. We can't make new primitive types. And so if I want to create an object of this type, we know that reference types store references to objects. So if I want to create a new object of the type person, and so inside of my person class, I have to create what's called a constructor. A constructor, as you might guess, is used to construct a person object. So the way we write a constructor is you just do the name of your class. A constructor for a class has to go within that class, of course. I couldn't put this constructor like over here, or outside here, or somewhere else. It has to go inside the class. And then what I do is I just put an open and close parenthesis and then curly braces for a body. And then inside of these curly braces are is going to be the body of my constructor. And so whenever I construct a person object, if there's some stuff I have to do, um, if there's anything I have to do, I can put that stuff in here. So I can just print out person object created. And so the way I create a person object is I just do new person, and then I just do it just like that with the parentheses afterwards. This is kind of like how we made a new array list, but on array list we had those like angled brackets and like types in here, which we're not going to really go over right now. So here's my person. If I run this code, whenever I say new person, a constructor is kind of like a method, in that like you call it from the outside world. You can think of it as a method that has a return type of person. So calling this constructor creates a new person object and like returns it. And so that's basically how we can create a new type and a constructor for that type. Now we can also create methods that we can call from any person object that we have. So let's make a new method called, it's going to say void. I'm going to say void because it doesn't have a return type. So this method's not going to return a result. But I'll just say hi is going to be my method. And then what I'll do in this method is I'll print out the text hi. And so now if I go over here and I say p.sayHi, it's going to print out hi. All right, wonderful. So classes, I also mentioned they can store variables. And here's how that works. So if you have a class, I can actually put variables right here in the class. And usually, if this class is obviously meant to represent a person, so maybe I store like their name here, or sorry, not their name, their age, and then their name here. These could be two variables I make in this class. And what I'll do is, I mentioned that constructors are like methods. So in my constructor, I can add parameters that are passed to the constructor. So I can have a string name. I'll put them in this order. It doesn't matter the order you declare your variables, but I can put a string name, my name, and then an int, my age. And then what I can do in here is I can assign the name variable of this class to my name, the thing you passed me as a parameter, and I can assign the age variable of this class to my age. And notice that these variables here, name and age, they are specific to each object, each person object I create. So every person object I create has their own name and age variables. So different person objects can have different names, of course, and different ages. And so now, whenever I create a name, I'll do me. My name's Sam. I'm 18 years old. And so this is how we could create a person object. And if I want to access one of these variables, I just print out my person object, and then I do dot the name of the variable. So if I print out p.age, that'll print out 18. If I print out p.name, that will print out Sam. So that's what we can do with a class here. Now, there is something else that's kind of similar to a class called an interface. So let's talk about what an interface is here. And let's see, let me just think about the order I want to talk about things. Actually, I think I'm going to mention one other thing before I get to interfaces, and that's what the word static means. So you notice I didn't use static anywhere in this class. So here is basically what static means. You notice how when I had this method, this sayHi method, I have to call it from a particular person object. If I just do like person, like the name of the class, dot sayHi, it doesn't know what I'm talking about. It actually won't let me do this. Because the sayHi method that I declared right here has to be called from a particular person object. And I'll zoom out a bit so you can see a bit more stuff here. Okay. Yeah. So, and I'll move this up to the top here. Okay. So, right. So, I can whenever I call sayHi, I have to call it from a particular person object. However, if I make a method that is static, so let's say I declare another method within this class, I'll do it static void. I'll just do like I can't really think of a thematic method here, so I'll just say like do stuff, and then this method will say I'll print out stuff is being done. Wonderful. And so now this do stuff method, because it's static, I have to call it from the class by typing the name of the class and then the method. So if I do person.doStuff, that works just fine. And so static methods you have to call from the name of the class. So you just do the name of the class dot the method. So you don't have to call it from a particular object. And we also call objects, we call them instances of their respective class. So this P object is an instance of the person class. If we created a string, it'd be an instance of the string class. That's just another thing we say. So the doStuff method, you don't have to call from any particular instance because it is static. So yeah, so when I do the doStuff method, it says stuff is being done. All right, wonderful. So now there's something else called, I'm going to make a separate file here, I think. Yeah, separate file here. If you have multiple files, for now you can just think that they're all in like the same space. So like just because they're in different files, I can still access them as if they were all written in the same file. So nothing to worry about there. So let's say I make something called an operator here. I'm going to put this over to the side so we can see both of them at the same time, both files at the same time. Okay, so there's something else in Java that's kind of like a class, but it's a bit different. It is called an interface. So instead of saying class and then the thing you want, you put interface and then the name of the interface. And so an interface differs from a class, and then an interface, while it can specify methods, it can't define what those methods do, which sounds kind of strange. So like to give you an example, let's say it has like an int, so this is an operator, so let's say like operate on. So a method that returns an int, and it takes as its argument another int. I'll just call it arg. So what I do is after I declare the header of the method, this top part, instead of putting a method body like this and then writing stuff in here, I just put a semicolon after the end of it. And basically this interface, it declares this method, but it doesn't specify what the method does. What this method does is going to be specified elsewhere. Now, if an interface specifies exactly one method in the interface's body, which is between these two curly braces, it is called a functional interface. So this thing here, operator, is a functional interface because it specifies only one method inside of its body. And so, whenever you have a functional interface, um, what you can do is you can use a Lambda expression to create an instance of that functional interface. So in other words, you can create an object that has this type, that has operator, this interface type operator as its type. So we can create an instance of the operator type. And so here's how we can do that. So let's say I create an operator here, an operator variable, right, a variable of type operator. Again, like classes, interfaces just define a type as well as doing other things like declaring methods. So interfaces and classes, they both define new types, like implicitly as a result of just declaring those classes or interfaces. So let's say I have an operator here. So this operator, if I want to create an operator object, what I can do is I can use a Lambda expression to create this. And so here's how a Lambda expression works. And you'll also see why the interface has to only have one method in order for this to work. So I look at the one method of the interface, and then I say, okay, it takes one argument, and that argument is an int. So what I need to do is I need to go over here, and in parentheses, I put in the arguments I want. So I can say int arg. Okay, so that is the one parameter of my interface. And then what I do is I put an arrow, and then, so a minus sign and then a greater than sign. And then in parentheses, I can put stuff here. And so these parentheses are actually declaring a method body. So these parentheses, they define the body of a method. And as you might suspect, this method, this body here, is going to be the body of this method right here in the operator interface that I didn't write. I know it might seem a little confusing, but as we do some more examples, you'll see what I'm talking about. So I'm getting a compile error right now because this method returns an int, and so I need to have a return statement in here. So I'm just going to return arg plus 1. That's all I'm going to do. So I need to return an int. The parameter is an int. I'll just return arg plus 1. That'll be my operator here. Okay, so this thing here now, again, it looks a little strange, but this thing that I just highlighted is an expression. And this expression has a value, and that value is of type operator, which means I can assign it to an operator variable here. So now I've created a new operator object. And when I call the method, this method on the operator object, we know now that it's a non-static method, so I have to call it from an object. Non-static methods are sometimes called instance methods, by the way. So I have this instance method on my operator. And if I call this instance method from my particular operator object, it'll run this method. It'll be as if the operate on method had this as its method body. So just to show you that, if I print out o.operateOn, let's say I operate on 5, that'll print out 6. And let me comment out this stuff up here, just so we can only focus on the operators right now. So I print out o.operator on 5, it'll print out 6. Let's say I make another operator. Let's say I make it q. So I say int arg. This is kind of like the little parameter list of a method here. And then I put my method body here. So let's say now this operator is going to return arg times 2 instead. And so now if I print out like q.operate on 5, then it'll print out 10. So you can see that operators, so interfaces basically, they allow you to be more broad because they don't specify the behavior of the method. So different operator objects can do different things when you call operate on them, which is a kind of interesting idea. They're more broader, they're less restrictive, and they let you do more, they're more versatile, I suppose, these interfaces. So that's basically what you can do here. Now, there are a couple ways you can write Lambda expressions even more concisely. The idea of Lambda expressions is they're designed to be super, super concise. So there are some things we can do here to shorten them up. So first thing we can do is that this type here, int, is actually optional. It'll be inferred based on what I put here. So like it'll be inferred based on the type that the parameter type of the actual method that I'm implicitly, writing the body of here. A lot of things are inferred, implicit here. And then another way we can shorten this is that if your method, the method you're creating the body of, in other words, the method that you're using the Lambda expression to implement, of course the Lambda expression also produces an operator object as a result, but this little thing I highlighted here is the Lambda expression. So if the method, the single method of a functional interface, by the way, is called the functional method. If the functional method only has one parameter, you actually don't need to put the parentheses around it here. So this is another thing we can do to make it a bit shorter. And then the name of the parameters here, they don't have to have the same name as we use here. So I could call this x and it'd be fine. And then this is the key part that really helps us make it a lot shorter is, so suppose that your body here, your method body here, all it consists of is just a single return statement. So it says return and then an expression. That's all your body is. Well, if and only if the body of your method just is a single return statement with an expression, what you can do instead, or one thing you can do to shorten it, is to delete the curly braces and delete the word return. And usually we'll just write this on one line like this. And so then it ends up as this here, which is very, very short. And so this is like the tiniest way possible to write a method. It's just saying take an x and return x plus 1. Like super concise, right? No extra details, no extra boilerplate, no extra stuff on there. Just the simplest kind of thing we can possibly have. So, right, and of course like the type of this variable, this parameter is inferred, the return type is inferred, the behavior of the body is inferred to just mean return x plus 1. A lot of things in here are inferred. The type of this expression here that I just highlighted, the type of this Lambda expression is inferred to be operator. So many things are being inferred and done implicitly for us in order to allow us to write super concise code. So this will still work as expected. O.operate on 5 will give me 6 here. I'm going to show you one more example of an interface, and then we'll go and do some coding. So let's look at another example of an interface. Let's make another interface here. And by the way, you don't need to use the word public here when you're declaring an interface or a class. Public, if you make something public, that makes it accessible to other packages. A package is just a big bundle of classes. So this thing here, if you notice at the top of my files, I have this thing that says package Functional-1. So this is the name of the package I'm working with. I just made a package for every section on CodingBat. So I'm in this package. So both of these files are in the same package. And when you write files that are in the same, when you write like types that are types, classes, interfaces that are in the same package, they can access each other. But if you make something public, it can be accessed in other packages. Now, we're not going to be working with multiple packages, so it doesn't really matter whether we make things public or not public. They'll still just be accessible because they're all in the same package. Okay, so let's suppose I make another interface here, and I call this like, I'll call it like, let's see, string combiner. Here we go, string combiner. So here's what it'll do. So it'll take, it'll return a string, and it'll say combine string1 and string2. Or sorry, I guess I gotta put the types here. So string, and the first parameter is going to be, I'll call it s1 and s2. So again, this is just the header of a method, but instead of a body, I've just used a semicolon. So that's my interface here. And so let's use a Lambda expression to create an object of type string combiner. In other words, to create an instance of the string of string combiner. So string combiner, I'll call it C, equals, and then I'm going to use a Lambda expression here. So I'm going to say, and remember, since this method here, the functional method, has more than one argument, I have to put the parameters in parentheses. So I can say s1 and s2, and then I can do this arrow to make the body of the method here. And so all I'll do is say I'll return s1 plus s2. We can do more interesting stuff in a second. But this is going to be my string combiner. And of course, as we know, if the body only contains a single return statement, I can shorten it up like this here. So that's how we could do it. And of course, the parameters don't have to be named. They don't have to be named S1 and S2. So yeah, and let me see just what is the problem here. Let's see. I'm not exactly sure what's going on here. Okay, I don't know. Wait. Do you have a problem? I need to see. Okay, I can't tell if it thinks I have a compile error or not. Sorry, it's being a little bit annoying. Um, so let's say I just run it. Okay, it's fine. Okay, so yeah, there was no compile error. Okay, so I have my string combiner object. I can print out like c.combine a and b, and this will of course print out ab, right? And then let's say I write another string combiner. I can say string combiner d equals, and again, the parameters can have different names, so I'll just say a and b, and it's going to be like a.substring 0, 1, so the first character of a plus like the first character of b. How about that? There we go. And I'll just print out, d.combine, you know, let's say cucumber and banana. And so that's CB, because it's first character of this one, first character of this one. Okay, so, and by the way, they don't have to all be the same type. I know I've used like int everywhere here and string everywhere here, but this could take like a int and a string and like return a list of strings, or, could be anything we wanted to here. No restrictions there. Okay, so that's basically a functional interface and Lambda expressions, basically. That is a simple, well, you can determine whether it's simple, but that is an explanation of those two ideas. So let's go back over to the functional-1 section here on CodingBat. So it says functional mapping operations on lists with lambdas. So you know what a list is, and you now know what a lambda expression is. You might not know what it means by functional mapping operations. And so a a mapping operation is just when you take like a list of things, and I'm using the word list in a more broad sense. I could also be referring to like an array or an actual like proper list proper in Java, or I could be referring to a set. But it's whenever you take like a collection of elements, like whenever you take a group of elements and you apply some function to each element in order to map it to another element. So let's say, like for example, I had a bunch of elements, and the elements were like 1, 2, 3, 4. And I applied the mapping function of tripling them. That was my function. My function, if you were to write it in math notation, the function I'm going to apply is going to be f of x equals 3x. Yeah, so just f of x equals 3x. That's going to be my function that I'm going to apply to every element here. And so we could say that that's my mapping function. And what's going to happen is it's going to apply that function to each number. So 1 times 3 is 3. 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. So that's what would happen if I applied this mapping function to my list here. Okay, so yeah, so that is what it says when functional mapping. That means mapping, some like a group of elements, whether that be in a list or an array or something else, and applying some function to every element. And of course, since this is Java, we don't just have to work with numbers. We could also, map strings or booleans or something like that. And you are welcome also to read this page here if you would like to. Yeah. Okay. And then, yeah, so it's basically also telling you that these your solutions here should be pretty concise. Okay, so let's do the first one. And I'm actually going to walk you through this one here because it uses some methods that you may not be familiar with. Yeah, so, and of course, like I have no doubt that you could do these problems without functional stuff. But of course, the purpose here is to use functional stuff. So to use mapping and lambdas and stuff like that. So we're given a list of integers, and we need to return a list where each integer is multiplied by 2. So there is a method, and this is a new method I'm going to introduce you to, so I don't expect you to know it. There's a method on lists called replace all. And let's go over to, not last, to list here. And look at the documentation and we can find the replace all method. It's right here. And so if we look at the replace all method, it takes one parameter. It is a unary operator. So unary operator is not a type we've talked about. So I'm going to just click on it and it'll take me in a new tab to this unary operator. And basically, a unary operator has one relevant method, and it's this method. It's called apply. And so this apply method takes a parameter of some type. T is just a stand-in for any type, and R is, again, another stand-in for any type. And so all this thing does is it takes an argument of one type and returns an argument. Okay? And so a unary operator, what a unary operator does is it's just like this apply method here, but R and T are the same type. So it's converting from one type to another value of that same type. That's what the unary operator does. And so again, it has this one important function called apply here. And that is the functional method of this interface. You might notice that it has like some other methods, but these methods are called default methods, and they don't count. Like if we look at this, it says it's a default method here, and they don't count like as, methods in the interface when I talk about, a functional interface must have one method. So default methods don't count. It must have one non-default method to be a functional interface. So let's go back and we see that replace all takes a unary operator, and the unary operator, the type that we're going to work with the unary operator, is just going to be E, which is a stand-in for the type of the elements in the list. So going back here to this, if we want to use a unary operator, let's first create one. So my unary operator is going to be operating on the type of the elements in my list. So in other words, it's going to be operating on integers. So I'm going to make a unary operator on integers. And so I can just call this op. I'll call it op for operator. And what I want to do is I want this operator to take one integer and return twice that value. Because the idea here is I'm doubling every number in my list. So it's going to take a number x, and I don't need to worry about, I can call this variable whatever I want, because, again, the apply method, as we just looked at it, it has one parameter. And I can call this anything I want. And then we know that R and T are going to be the same type, because this is a unary operator. So, and unary generally means, from one type to the same type. So I'm going to take one integer x, and I'm going to return x times 2. Right? So that's going to be my unary operator. This lambda expression here is going to create an object, and that object will have type unary operator. So this is an instance of, the unary operator thing here. So now I have my unary operator, and what I can do is I can call the replace all method from my list, and if I pass it the unary operator, this method will apply that unary operator to every element in my list. So in other words, it's applying this function here, x goes to x times 2, to every element in my list. And now if I return my list, you'll see that, okay, so CodingBat doesn't import the functional types for you, even though the section's called functional, which is really dumb. I don't know why they don't import it for you when the section is literally all about functional stuff. So because they don't import it, we're going to have to actually do the full name of the unary operator type, which is java.util.function.unary operator. So that's the full name. And because CodingBat doesn't import it for us for I don't know what reason, we have to type out its full name. But that's the full name. And now if we do that, it will work. And so basically we've created a unary operator. This is what it does. It takes some number and it multiplies that number by 2. And so we're going to use the replace all method to apply that unary operator to everything in my list. So all of that, almost 30 minutes of build up of this episode so that we can talk about this code right here and actually do this problem here. So we can make this code more concise by eliding this variable, and that's the crucial step here, is that we're going to just take this lambda expression and just put it straight in here, not even have an op variable at all. And so what you can see now, this is of course still going to work, but what you can see is that we're using unary operator, right? We're using that type, but we're using it implicitly, right? Because I know that the replace all method takes a unary operator as its parameter, and this lambda expression creates a unary operator. So I'm using the unary operator type without even explicitly mentioning it here. So this is how you could do this problem here. Now, again, I'm going to show you alternate solutions, and I'll show you one alternate solution to this problem. So I could say return nums.stream.map, and this is another Lambda expression. In fact, this is another unary operator here. Dot map, so this map applies this mapping function, and then I'm going to do dot collect collectors dot to list, and that will convert it to a list. Okay, and so this is another way to do it. I'll give you a brief explanation of this, but again, it's something you could go into a lot on your own. So we take a list, and if you call the .stream method from a list, it converts that list to a stream. And a stream is another type that has a bunch of useful methods. One of those methods is map. And the map method takes a unary operator and applies that operator to every element in the stream. And then in order to get from a stream back to a list, I use this thing right here. I call the collect method. And if you pass the collect method, the result of collectors.toList, collectors.toList is another method. But it produces a result that you can pass to the collect method to convert a stream to a list. And so this will let me also do this problem here. So yeah, we're not really going to focus on streams, but all of these problems in the Functional-1 section, in addition to being able to be done using the stuff that I'm going to show you, will also be able to be done using streams. So that's how we could do this problem here. All right, now we are given a list of integers, and we need to return a list where every integer is multiplied with itself, so every integer is squared. Pause and try this one. All right, so this one is very similar to the last one. I'm just going to say nums.replaceAll x with x times x. And I just return nums here. And that's how we do this one. If we want to do it functionally, or sorry, not functionally, if we want to do it using streams, we can just say return nums.stream top map x to x times x dot collect, and I'll just split this up to the next line, collect collectors.toList. And that's how we could do this one. Okay, so we're given a list of strings, and we need to return a list where each string has a star added to its end. So you can totally do this using what we've talked about. It's just a little different than the last two because we're working with strings, not ints. Go ahead and pause and try this. Okay, so I'm just going to do nums.replaceAll, replace every element, every string s with s plus a star. So that'll add a star at the end of every element, and then I just return nums. And it's not called nums now, it's called strings. There we go. All right, given a list of strings, we're to return a list where each string is replaced by 3 copies of the string concatenated together. Pause and try this one. All right, so hopefully not too hard. We just say strings.replaceAll s with s plus s plus s, and we return strings. If you wanted to do this functionally, or not, again, not functionally, I'm sorry, I keep saying that. If you want to do this using streams, we can say strings.stream .map s to s plus s dot collect. I'll put this on the next line. Dot collect collectors dot to list here, and that's how we could do this. All right, given a list of strings, return a list where each string has y added at its start and end. Pause and try this. Okay, so again, hopefully you could do this one. Replace s with y plus s plus s plus y. So as you can see, we did a lot of build up to get here, but now that we're here, we're rolling through these problems pretty quick. It's just that I want you to understand what's going on behind the scenes and not just, be confused like what the heck is this arrow doing in this lambda thing. Okay, so that's how we could do this one. I honestly think I've given you enough examples so that you could do it using streams if you wanted to. Okay, so given a list of integers, return a list where each integer is added to 1 and the result is multiplied by 10. Pause and try this. All right, so I'm just going to replace each number with that number plus 1 times 10 and return nums. All right, so given a list of non-negative integers, return a list an integer list of the rightmost digits. Pause and try this. All right, so we're going to replace all numbers with that number remainder 10 and return nums here. And that's how we could do this one. Just map each number to its rightmost digit, or in other words, replace each number with its rightmost digit. All right, given a list of strings, return a list where each string is converted to lowercase. Pause and try this. Okay, so I'm just going to do strings.replaceAll replace all s to s dot to lowercase, and then return strings. That's how we could do this one. Now I can actually replace this lambda expression with this other expression, string : length. And this thing, string : length, is called a method reference. I'm not going to spend any more time on method references than literally just right now, because there's nothing you can do with a method reference that you can't do with a lambda expression. And that's why I'm not going to spend time on them. There's just like a bonus feature if you'd like to dig into them on your own. Let's see, sorry, not string.length, string.to lowercase, string : to lowercase. So it's a method reference because it like is referring to this method here. Yeah, sorry, not string length. Okay, but yeah, this is another way of writing this. Again, there's nothing you can do with a method reference that you can't do with a lambda expression, so you don't need to know them. Lambda expressions will always work. There's a shorter way in some cases than writing a lambda expression. All right, so given a list of strings, return a list where each string has all of its x removed. Pause and try this. All right, so hopefully you use the replace method on strings, in addition to perhaps the replace all method on the list. So I'll say strings.replace every string with that string after you replace all x's with nothing. So that'll remove x, all x's from the string, and then I just return strings here, and that's how we could do this one. All right, so that's the functional method. We spent, I think, more time, building up to it than actually doing problems today, but that is all totally fine. But yeah, as you can see, using lambda expressions, in addition to the built-in useful methods such as replace all and streams and unary operator and all these nice types, you can do a lot of things, pretty complicated operations in a very concise way. So that's the whole idea with functional stuff here. So in the next video, we will finish it off. We will finally be done with CodingBat, and we will have all the stars. All right, I will see you then.